So I'm back at the case here where I've just introduced a 1 hertz frequency offset. And so we're seeing essentially that vector spinning around at a 1 hertz rate. Now what that represents again is that the carrier frequency in this case, say, is above the local oscillators. Now if I simply invert one of the quadrature oscillators, basically introduce a 180-degree offset to it, I can essentially make, reverse which of those two signals is leading. So if I dial in a 180-degree offset into one of those, now I can see the vector spinning in the opposite direction. So when it's spinning in this direction, for example, this might represent that the RF signal is now 1 hertz below the local oscillator frequencies. And in this situation, it's 1 hertz above. So we can introduce a frequency offset in one direction or the other by simply changing the phase between 0 and 180 degrees, and essentially it's just inverting or not inverting one of those quadrature local oscillators. So we can actually change and select whether we want a positive or negative frequency offset by simply changing the polarity of a multiplier. Now, this same concept of being able to select, a higher or lower offset is also the same principle that was used for the phasing method of single sideband generation. In that phasing method, the audio signal is essentially passed through a 90-degree phase shift network. And that's probably the most difficult thing to do, is to get a good 90-degree phase shift over the entire audio passband that you want to do. And then those two signals are passed into our double balance mixers driven with a quadrature local oscillator. And then the output, if you add them, you get one of the sidebands, like the upper sideband. And then if you subtracted them, you flip everything over to the other side of the carrier and get the lower sideband. So this phasing method was actually used, for a long time, and still is used today by some people to do upper and lower sideband signal generation, rather than using the filter method where you're filtering away the unwanted sideband in the carrier. Another variation of this is called the Weaver method. And the Weaver method basically substitutes this 90-degree phase shift network for the audio signal with another pair of quadrature mixers. And the audio signal is passed into that. And then those mixers are used to create the audio quadrature signals that are then fed to the next quadrature mixers to create the components used to generate the upper and lower sideband RF signal.
Okay, I think we covered FM, we covered AM, and SSB. So is that sort of, are we totally lost now, or are we?
What's the next down on the right? Now I can understand now. When I read something, I know because I didn't know what the terminology was.
Yeah.
Now I can start understanding what the terminology is.
Yeah.
This is different from straight the manuals what I learned, FM, AM, correct. So you just got different wording for the digital side.
So now it's purely either phasing of this IMQ or the amplitude of this IMQ. You can generate any RF signal, which is actually quite nice. It's a simple way of generating RF. So I think we're going to leave the videos here, and then we'll carry on with the agenda.
We've got 13 minutes.
13. Yeah, just give me a shout in the
13 minutes. Till the end. No, just to make sure.
Right.
Okay.
Okay, so I want to discuss some issues. Remember, we saw on the SDR menu on the side, we had the DC, let's call it the marker, it's a DC offset on the two A2Ds. Basically, you see the analog signal that's the A2D is reading the INQ signals now. But there's a little bit of a DC offset between the 2 points. You get like a sharp carrier in the middle of your spectrum. You'll see it there. Now that's depending on the quality of the A2Ds and the IC coupled or not. You can get that DC offset. So that is one factor that you will know that SDR is producing right in the center, which could be an issue. Then we've got your local oscillator, which is the actual RF oscillator. If it's got a bad phase noise on it, then obviously you're going to get noise in the sampling. If you've got also the if these 90-degree phase shift devices here, it's not 100% linear. Let's say it's not 100% linear over the whole frequency, then you might also get offsets in the actual measurement. So that could be a factor that could influence the accuracy of an SDR. And then obviously the gain imbalances of the actual mixers itself. If there's, I mean, they're still analog devices at the end of the day, so there could be those factors. So that's really the factors that could influence the accuracy of an SDR. So that's something, if you're going to buy an SDR, that's the things that you should look at. The other thing you should look at is the sampling rate. And then the other one you should look at is the bit. How many bits defines the actual analog signal. 8-bit, obviously the higher the bit. So that's sort of the factors around that. This we've covered. Okay, so I'm going to now go on to satellite capabilities of SDR. Because you can now put the Raspberry Pi antenna, you don't have those losses on the codecs at high frequencies if you want to execute. So how do we integrate our SDR with all the software we need? What software do we need to do satellite capabilities? I recommend a tracking software called gPredict. And for instance, the gPredict application, I've got another little video here. This is what I would do, and this is a video I've recorded to prepare, so this is FunCube 1. Let me just maximize it if I can. So basically what I would do here is, the satellite interest, you will select the satellite interest, you will select what time it will come up, it will show you the path it will come up above you. So you can see this one came across almost dead center over me. So this would be nice. There's the actual elevation. So you can see it was a pretty good pass. Now the problem with this specific satellite FunCube 1, its batteries is bugged, so it only works in sunlight. And when I did this recording, it was like early in the morning. It sort of just worked a little while before it went into the dark. So that was the preparation, and it was pretty simple. You could see I just went in there, and let me show you practically how to do it. Okay, so this is how the software looks like when it starts up. You will not have all these tabs here at the top. You only have one. So what you would do then is you basically will go here, you say update LTE from internet, so all your Kepler elements, it will go and fetch for the satellites, and it will collect everything, all the satellites that's almost available except the military ones. And once you've done that, you know your data is up to date. And then you will have to now select the satellite you want to do. So you'll say new module, file new module, and you'll give it a name, let's say my satellites. And then you have to select which satellites you want to actually track. That's pretty easy to do because there's a pull-down list here. In my case, I'll just say amateur, or let's say weather. Maybe there's weather satellites above us. Maybe we can look at them quickly. So we'll take all our NOAA's, I think all these are working at the moment. I think 16, 17, 9. Okay, so now we've created this new tab that says My Satellites, and we've got a view of all the satellites of interest. And we would now like to maybe do weather satellite encoding. Yes?
What satellite program is that?
G-Predict.
D-Predict.
Here.
GG.
Golf. It's also on that memory stick. If you got them, I've got spare ones. Afterwards, come talk to me. It's all on there. But basically, that's what you'll do. And what's a nice feature here is on the right-hand side, you have a pull-out menu and says Sky at a glance. Now, what this does, it will basically tell you at what time of the day will these satellites be coming past. So now I can say, you know what, the next one that's going to come past NOAA 70, if I click on it there, it gives me more details around it. Now if I even want to know what is the view angle from my position, I actually forgot that you have to put your own station's position in. It's related to your own station, we'll cover that now. But that basically says it will be on the eastern side of my house. Now, normally you can only work satellites if they're above 10 degrees. If it's below, it's not really advisable. So this one is pretty bad. But this will also, if I click on this tab, it will actually give me my elevation angle, and that's the azimuth angle. So this program is also capability to control rotators and things, but I'm not a big person for direction antenna, so I would recommend use egg beaters or cross yagis or something like that. I sell them as well. If you don't go to my website, you can find all the stuff there. And they're pretty easy to set up. It's one you set up and it works. Okay, so once you've done that, you can then run your SDR software, which will basically be this software, and you can actually hook the two up so it will even compensate for Doppler. If you actually physically there, you don't even need the Doppler adoption. It's only if you're not there, then it can do it for you. Otherwise, you just manually tune it as the Doppler comes across. Okay, so basically, I'm going to take you to, I can either show you a video how the actual signal looks like on the screen, but I think we've had enough videos. So what I'm going to do now is I'm going to just show you an audio file that I've recorded. I'm going to show you the software you're going to use to load the software, and I'll show you a picture. So the software that I'm going to use is called WeatherXSat. So you've got WeatherX image. You get it now? I think we're a bit limited at time, so I'm going to rush it a little bit. But basically, if you look at SDR Sharp, there was a recording capability on the left-hand bottom side. You've recorded the audio. You will open up this app. You will go here. You will select Find Open Audio File. I think I've got one audio file on the SD stick as well. So as an example, you can get it off the stick. Maybe some files here. I don't know how good quality they are. I'll just load one. Nope.
Is that the image you're picking out? After you decode it.
No, you can do overlay. So that map is an overlay. You can put overlay over your map, so it actually have the lines. Sorry, these are over. Let me just go and fetch one audio file from my system. I'll show you. I've got a live system on my site. If you go to this ZR6.giga, there's like an index page. And if you scroll down to the bottom, I've got NOAA weather satellite. And this is a real-time system that runs here continuously. So what I'm going to do, just show you a picture how it looks like. If I go here, it's all the audio files I'm collecting. This is for the last 3 or 4 years. I've got all the audio files. You saw it 2017. So this was taken today, 7:38 this morning. I'm going to play this audio file. I want you to hear how it sounds. So this is what you're going to hear. You're going to put it on FM. You're going to open up the bandwidth a little bit. It's not 25 kilohertz, it's a little bit wider. You'll see it's like lines coming down on the waterfall. It's like 5 or 6 lines. This is how it's going to sound. And you're going to record this. And later on you can actually use virtual audio cable so to do it automatically. And I'll show you how to do that as well. Just waiting for it to download, and I'll show you a picture. This was taken this morning, but basically that's how simple it is. You download the audio file. I must tell you which frequency to listen to, so that's quite important while this is downloading. So if you look into this application here, WX, there's a setting here on the side that says update Kepler elements. So you'll let it update the satellite details. Then you say satellite pass list. No, it's outdated. And then it will tell you the time that will be over you and what frequency. You see this one here is the frequency. So you'll go and listen on that frequency at that time, and the satellite will come over. 137 megahertz. So, and it's pretty simple to build an antenna. The dipole is about this wide, so you do build a cross dipole, hang it off, fix it up, no problem. So it's quite a nice thing, especially for the ship here at the coast. If you publish your weather charts for the area, I think it's quite a nice thing to do. Okay, so hopefully it's not done yet.
You're not simultaneous. They don't come on simultaneously. One comes over. So you go and you record the audio and you change. Not all of them.
Okay, so this one was taken 16:04 yesterday afternoon from my house in Durban. So I must show you some things that you need to play with in the application.
Thank you, sir.
You'll see there's different patterns and things that you can apply to the actual image. And how you do it, once you've got this one loaded, you see, yep, it's downloaded, so I'm going to just open audio file. Okay, this was not a good picture. But in any case, I just want to show you some concepts. If you go to enhancements here, you can enhance a picture by using, you'll see the pictures at night that you download at night, it's infrared pictures. Then you have to apply a different filter to them to actually make them visual.